So here we've defined the line, the path, added the path to the line, created a line symbol that's dashed a bluish color using dojo color of a width of 4. I've added the line graphic with the first 2 options, properties. We'll talk about the next 2 in a bit. And just like we added the points, I will add the line graphic. And I will view in browser to see what it looks like. And I've caused an error. We're getting a lot of debugging in today. Notice they didn't show up. And just to review, I hit F12 to bring up the Chrome console. And I already see what the error is. My line is not defined on row 63. And remember what I said about case sensitive? The variable is my line, all lowercase letters, and I accidentally used a capital L. So that's why that error happened. Remember, the variables are case sensitive. So let me address that. View in browser again. More errors. F12 for the console. It looks like I did the same thing. It's very easy to do that. My path was all lowercase, and there I used a capital P here. In browser. Oh, good. That's all. Those are the only errors. So there's our graphic line. Just meanders its way through Western New York. And I guess 120.00 is kind of maroon. It's not blue, like I said, because the 120 is red in RGB. Any questions? And as you might have guessed, we create a polygon object now. We've added a line and a point. Let's create a polygon. We'll talk it through and then I'll do it. We create our polygon. I'm doing this very similar to the way we created the polyline. But this accepts a ring. Similar to the path, very similar to the path, a ring is a collection of points. But with a ring, if you want a valid polygon, it's critical that it should close. And note here, in my example, the final point in the array is the same as the starting one. Because we've got points, we're connecting the dots, but we're coming back around to connect to the first starting point to make it a polygon. Other than that, this is very similar. One other minor change is that we will use a fill symbol. You might have guessed that instead of a line symbol. The process is very similar. So let's give you a chance to practice that, or at least see it. We already have MSR defined for WGS84. So I'm going to create my poly, as new ESRI polygon MSR. I'm going to create a ring, my ring, and it's not any object, it's just an array. Sometimes for me, it may not work for everyone to help with all the different brackets. I'll make the empty brackets first and then backfill. Like I've filled in the array square brackets. I might even put the semicolon in, and then I go back in and start typing. So there's our first point. And just to be consistent, I will put MSR on all these. I'd have to look back to the API. I don't think it's required, as I said, because it's geographic, but I will put them in. So now I have a ring of these 5 points, that connects back to itself, which basically is the definition of a polygon. And I'm not gonna pay attention to my capitalization this time, and I'm gonna use the add ring method on my poly and give it my ring. Now, the next step, again, we have our geometry. What's step 2? The symbol. And we use a simple fill symbol. I'll bring, just to reiterate, the different constructors, the different possible ways of creating it. I'm going to use the blank constructor and fill in the properties later, but you could always give the style, outline, and color right in the constructor. That's what we did for the line, so I'm doing something just to be different. Or you could build a JSON string. So I've created a blank simple fill symbol with the constructor. And I'm going to set the style. Simple fill symbol, style, solid. Let's bring that up just to show you. In the documentation for simple fill symbol, you see that there's a variety of simple fill options available. Solid would be most often used, or null. Use style null if you want outline only. If you want to create a polygon that has outline but no fill, style null is what you would use there. I think that's the same as arc objects. I can't remember. And then we need to give a color using Dojo color. And what did I do? It doesn't really matter what I did last time, but I'll be consistent. So I create a color that's 200, 240. I kind of think that might be yellowish, but it's going to be half transparent. And now that I've set the style, I can create a graphic, new ESRI graphic, and give it, like we have seen twice already for the point and line, we give it the polygon and the fill sim. We will get to those other two attributes yet, I promise. And then we'll add this graphic in the same approach. Questions? No errors this time. So there's my polygon representing a 1 degree by 1 degree grid that we're within here. So it is a yellowish grid, and it's half transparent per that 4th number in my Dojo color array. Questions? Oops. So just to reiterate there, we accept a ring, create the fill symbol in a very similar way that we've seen in the previous examples, add the polygon, and there it is on the map. Just to be complete, we'll go through adding a circle. There's some complications to this that I didn't find documented, but I found through my own experience. I think You know what, in Dojo require, I didn't have to require point, line, and polygon. Esri geometry is sufficient. But I need to explicitly require circle, and I'm not sure why. Circle was added to the API later, and I have to wonder if up until fairly recently there was no circle. I remember at one point us having to write a complex JavaScript to create a circle using trigonometry. I guess it's not that complex. Now they've added a circle object, but I'd forgotten that we need to do this, and creating this example gave me a little bit of heartburn. I eventually remembered that we need to require the circle to create it. Excuse me. So I'll just we will Dojo require Esri geometry circle. And let's add a circle to the map. And there's a couple of different constructors, as there always is. As you see, circle was even more recent than I remembered. Circle was only added at version 3.8, one version ago. And we have two different constructors. You can input a center using a lat long, and then an object with the properties radius units, whether the circle is geodesic, and then the number of points is an option. And that's the one I'm going to do in the example. The other option would be to well, it's very similar, I guess, would be to specify it all in a JSON object. So to create our circle, I'll call it my radius. The first parameter will be a coordinate pair. I'm going to try it without the WGS84. And then a JSON object with a variety of, and that's a square bracket, a variety of attribute values. Radius, I put the radius of 1, heck, I'll make it 10, but we don't know the units, so I need to do radius unit colon esri.units.miles. There's a units class in the SRI, and here's the different options. Like some are for areas and some for lengths. You can see miles, kilometers, acres, and so on. It's out the constants out of the SRI units property. It's a geodesic circle. So now we have a circle with a center point roughly at this building and go out 10 miles. I'm just going to copy the same fill symbol because the fill symbol would be the same as for a polygon. Maybe I'll change the color around a little bit. So I'm going to create a radius graphic with my radius and fill sim. Let's add the graphic. And see what that turns out. Error. F12, undefined is not a function, line 85. Oh. See what I did? This is line 85. Typos, there's no dot between geometry and circle. There we go. So here's our 10-mile radius of campus, or specifically of this building. I guess I live a little more than 10 miles away. And remove the USGS layer too. Any questions? And so there's a result just with a different color, and I guess I mentioned that on the slide too. This is just 2 versions old. I do remember having to jump through hoops to get a circle before that. We basically wrote, it was a JavaScript for loop that used trigonometry, where it was a for loop that looped from 0 to 360, and for every degree it would take the sine or cosine of, I need math class, to get the angle, and then project a point out at that angle at the same distance, and if you scroll through 360 times you would make a circle. So I guess it's not that bad, but the less trigonometry the better. And it's a lot easier to do now that there's an actual circle object. So, I mentioned we would get to, there's 4 different properties of a graphic. With graphics, unlike ArcMap, we can add attributes to our graphic, and we can add an info template, which is like that pop-up. You can sort of do that in ArcMap too with the HTML template on a layer, if anyone's ever played with that. So let's add, in the simplest form, I'm going to add attributes and an info template to our example with the circle. Without doing that, notice there's no graphic or any pop-up. There's nothing to display. So I click on the circle, I'm zooming in on the map, but nothing pops up. We're about to change that. So instead of just ending with the 2 properties, I am going to add attributes with, I guess, JSON. So I'll start with a single quote. This is a little different than the example on the slide. And I'll just add some attributes and values to the circle in JSON format. So now I have JSON text. I will add that as my 3rd property. And I will create an info temp. And add that as the fourth property. And just to reiterate, the attributes is the actual data you're attaching to the graphic. And the info template defines how the data would appear. We'll do a more complex infographic in a couple slides. But if you don't specify any formatting, here I've just given the infographic the title. You'll see how this looks in just a minute. So now it looks the same, but notice, oh, it's doing that. When I was playing around with a bird example using Cornell University's eBird to try and capture people's bird sightings that they put in their iPhones and map them, and I kept getting this where it's putting every character on a separate line, and I never did figure it out. What's odd is when I developed the course, the slides, that wasn't a problem. So what I'm going to do instead, I'll do exactly what I did in I do have an extra. No, that still does it. Instead of creating a variable like that, I know what exactly did I do? I'll do set attributes. That's exactly what I did. And then I use red graphic set info template. And I didn't construct with all four properties to start out with. Let's see if that. And I cause an error. Rad graphic is not defined. Yep, it's radius graphic. Huh. And now I know how to solve. I stumped people when I posted it on the forum too. It looks like this is what I was expecting it to look like. There was circle info as a title, and there's the attributes that I pre-canned for my circle. So it looks like I get better results by assigning the attributes and info template after the fact and initially constructing the circle with just the radius and fill symbol. Strange. And that's how it should look. You can actually, by default, it has a zoom to link on it, the default info template, and if you click it, it'll change the map extent to zoom to the selected feature. Any questions? We can take the info template a step further, and normally you would. The whole point of the info template is allowing us to define more closely what the content will be. I can do that with set content. We note these two methods. Set title lets us set the title of the info template, and then set content allows us to insert HTML to define how the template will display. So you'll notice this is HTML that we looked at the beginning of the class. There's one other thing I have to point out. If you want to get to an attribute within the info template content, notice the format. $, and then the name of the field or attribute within square curly brackets is the format if you want to display an attribute in your HTML. So I am going to set the title and now for set content I'm going to insert HTML code and I'll mimic what I did in the example. And just to review, I'm creating a table. I start out with a table row, TR. We didn't do much. Table TH is table header. So here I'm accomplishing two things. This is a table header, not a TD, a table column. So it'll be a bolder format. Colspan 2 on a table TD or TH is like merging cells in Excel. This TH will go across 2 columns, and you'll see what that looks like when we're finished. And I think selecting 2 adjacent cells to the left and right in Excel and selecting the merge option, if you're familiar with Excel, would be a good analogy to this. So now I'm going to end that row, start a new row. I'm going to do a regular TD for a column this time. And I'm going to create a second column. Remember the TH spans 2 columns. I'm going to end that row and start a new row. I should have picked an easier example. It's hard to read. TD. I'm going to start up a new column with TD. And notice my nomenclature. $, X chord. So that will pull the value X chord and insert it in that location. And this is very similar to what you did on what we saw is possible in ArcGIS Online with the setting configure pop-up. We looked at that Monday, and if Lab 3 will do that. We're doing pretty much the same thing, but now in a JavaScript API environment. So I'm going to finally add another row on the bottom spanning 2 columns. And just to reiterate for you that this is HTML, I'm going to add in an image. Close my tags, and there's no way this is all right. And so now I've changed the title and content of the info template. So there we go. So now it's inserted the image into the info template, not unlike what we did with the flags on Monday. Questions? And notice, I guess GEO503 I put in directly, but notice the attribute showed up because I pulled the attributes using that $ notation for X chord and Y chord. So an example of formatting our own info template on a graphics layer. You can also do that on a feature layer. This example happens to be with a graphics layer, but you could do the same thing on a set of features coming from a GIS data set. It doesn't have to be a graphics layer. So to summarize key points with graphics that we've talked about, every map by default has at least one graphics layer that's automatically created once a map is loaded. I mentioned that earlier. And we've been accessing it with map.graphics. You've seen me type map.graphics.add a bunch of times. Doing that accesses the default graphics layer. If you remember back to summarize, when we started doing these examples, I mentioned that we placed them in the onMap load event. See where I put all this? So that onload event's gotten pretty big, hasn't it? We put it all in the onload event that we connected with Dojo because the graphics layer is not available until the map completes loading. So I want to summarize that point. A couple additional we actually do this later to some degree when we work with feature queries. Not at this hour. It'll probably be first thing Monday, not tonight, or at least start talking about it tonight and pick up on Monday, the 23rd. Additional graphics layers can be added. I mentioned that already, and two other things you can do with a graphics layer that I haven't explicitly shown you, but I think are important to mention. Map.graphics.clear would be like the clear selection button that would remove all the graphics. Or in code you can have .remove and remove one particular graphic by its name. So those are two other, I don't necessarily have an example here for that, but I thought it was worth noting. And here is an example for you of adding, I think I showed you this is right from the documentation. Here's an example of adding a new graphics layer. And often when you're working with a layer that's more dynamic, it's often a best practice or a practice programmers employ to put the data in a graphics layer where you can remove and add features more easily. I showed the example of the crime map where that map updates every 4 hours. It shows a two-week crime window. So that's a pretty dynamic layer. And for that's the reason that Matt, the developer, wrote it as a graphics layer. In this example, you may also often work with graphics layers if you're working with selections. And we'll do that certainly on Monday at this point, not tonight. But here's an example from, not my example, but from Esri, where we've created a new graphics layer called county layer. So you might guess where they're going with this. And they set an info template like we just did. So I guess the whole purpose of that is just to reiterate that you can add additional graphics layers onto your map and work with them just like you would a dynamic map service layer or a tiled map service layer. It's more like a dynamic map service layer than a tiled layer. What time is it? It is, we'll talk a little bit about this, and then it's 9:15. We'll start talking about feature layers in the ArcJavaScript API and then continue that discussion next Monday. Feature layers are an extension, so when I said they're more similar, I wasn't kidding. They're actually an extension of a graphics layer. So a lot of how you would handle a graphics layer and a feature layer are the same, but a feature layer grabs its graphics from a GIS data set. You don't have to draw a circle like we did or draw the polygon. Those graphics are automatically brought in from a feature layer that you specify, using the REST services like we've been looking at. A feature layer is very similar to ArcGIS, the Esri ArcGIS dynamic map service layer, but it's not exactly the same. They're very similar though, and easy to confuse. I find myself doing it as well because they're so similar. But here are the differences. With a feature layer, as I will start working with these in earnest on Monday and for the rest of the class, it's client side. The geometry is actually transferred to the client. Where dynamic map service layer is a little more like a tile layer in that the features are rendered and drawn on the server. So feature layer transfers the actual geometries to the client right off the beginning when they're loaded. So when your map loads a feature layer, the features are shifted to the user's client, cutting down on network traffic and increasing speed because the API is operating on those features right on the person's local machine. Queries and selections can thus occur locally. This also lets us work with feature attachments and access related tables. We don't have time to get into much of that. The map service provides the dynamic map service, so to make that last sentence clearer, provides geometry and attributes just like the feature layer, but it needs to be retrieved from the server and symbolize yourself every time. So the difference is not great. A lot of the same concepts and same properties and methods even, but one of the big differences is the location of where the processing occurs. And I've mentioned this, I think I just copied this slide from earlier, but just to review that. If you want when you're publishing a service, if you want feature access, if you want to be able to create a feature layer from it in the capabilities, you need to check on feature access as an option when you're publishing the layer. Otherwise, you won't. If that's not checked on, you won't be able to create a feature layer from your REST service. Any questions? There are 3 ways to stream data locally. Remember, we're transferring data locally. So once it's there, it's fast, but that transfer could be an issue, especially with larger data sets. And there's 3 different methods in which to stream feature layers. The first is called snapshot mode. And in snapshot mode, I want to say this is default. All features in the shapefile, it's not really a shapefile, but I call it, are streamed to the client. So all the geometries in that layer get sent to the client's machine. So that's the fastest if it works well, because there's no need to go back to the server to run queries on that data set. All the geometry is local. By default, this is only 1,000 features at a time. Once you get, and I can vouch for this, although I have to say that this is with every version this has become less of an issue. Around 9.3, that was a serious issue. It seems faster, especially at 10.2. More than 1,000 features, this starts to become problematic because you're shipping a lot of things, shapes, to the user. You can, in an ArcGIS server setting, you can increase this count if you want beyond 1,000. So that's called snapshot mode. On-demand mode is the next option. It only retrieves features as needed. Use this for large data sets. If you want to use a feature layer on the parcels of Niagara County, you might not want to do that. You don't want to necessarily try to send 93,000 parcels to a person's client machine. But you could use on-demand mode, so if there's a scale tolerance and the user zooms into Cambria, a particular neighbor, Bergholtz, the neighborhood, it's only going to stream the layers in the map extent, or the features in the map extent. So data is only requested within the current view extent. That obviously cuts down on traffic when you're dealing with a largish data set. So that's the plus side. The downside is there's more round trips required. As soon as the user pans to a new spot, it's going to have to re-download more features from the server. Each one of these has its own pros and cons. That's why there's 3 options. If one of them worked best every time, there wouldn't be 3 options. And then in selection only mode, you have all the data on the server, and if the user issues a selection, only the selected features are transferred to the client. This is most often used for highlighting features, just like you would select features in ArcMap and they turn blue. And to do this, we go directly to the feature layer, but we need to make sure that we click on the feature server map service. And again, that assumes that that option was checked when the feature was published. So I still have a So here, if I go to my test Niagara Maps REST endpoint, notice that there's 2 map services available. Under this map service, there's 2 servers available. The map server is what we've been working with today. That is the dynamic map data. It is dynamic map services and tile map services. But notice now this feature server is also available, and I can click on that, and then this would be available to us as a feature layer. So again, unlike the dynamic map service layer, we would be able to stream these locally. I will just describe this and then we'll end. It's a little after 9:20. So we will pick this up on Monday, but this shows how you can create a feature layer. Notice instead of ArcGIS dynamic map service layer, it's esri.layers.feature layer. We provide a REST endpoint URL right to the specific layer. Now it's got the /0, and notice instead of map server, it says feature server. So those are the main differences. Feature layer, not dynamic map service layer. Feature server, not map server. And we've done that a couple times already anyway, but you go right to the layer. Many of the other properties are the same, but now, of course, because it's a feature layer, we specify the streaming type. In this case, I've selected on demand. I can only request, and this can be a good practice if you have, I'm thinking of something like a county parcel layer. Niagara County has many, many columns. They may have 50 or 100 columns in it. If your application only needs 7 attributes of the parcels, just bring over that 7. Remember, we're not dealing on desktops, we're dealing on the internet where you really have to think about speed. So in this example, what are these? They're counties. In the example to work with Monday, I'm only interested in the state name, the county name, and the population. So that's all I bring over. So when the county shapes are streamed with attributes, it's only going to stream those 3 layers, and it's going to ignore all the other columns because it's only going to stream those 3 columns, and it's going to ignore the rest because I don't need them. And here also I've set up an info template right on the layer from the start. Some of the other options with a feature layer are listed here, but the key things are noted in the slide. And I said, what is that? That's slide 36. And I think we'll end for tonight. Are there any questions before we do so?